talk about domain and range. So this is a function f. When you input x into it, then the output will be f of x, or you can think about this as y. Okay. Now, the set of all possible input, or in this case, all possible x value, that's called the domain. Okay. In Chinese, we call that 定义域, and in Spanish, it's called domino. Okay. Now, what's coming out of it, okay, is f of x, and this, or you can think about it as y. So the set of all possible outputs, all possible y value over here, that's called range. That's called the range. That's called the range. And in Chinese, we call that 值域. In Spanish, we call that rango. Okay. So remember, domain is all possible x value. Range is all possible y value or all possible output value. Okay. So think about this in alphabet order. X is before y, and D here is before R. Okay. So domain for this, range for this. Okay. Now we try to find the domain for the following functions. Number one, f of x equal to 3x plus 1. Now think about what can we put into x, because domain stands for all possible input. So what can we input into x over here? Can we substitute x by 0? Yeah, that way f of x will be 0 plus 1, so will be 1, right? So 0 is okay. What about positive number? Can I substitute x here by any positive number? Yes. Can I substitute x here by any negative number? Yes, right? So looks like we can substitute this x here. We can input into this x over here any real numbers, any real number. So the domain for this function will be all real number. Now we have a notation for all real number. It is R with a double bar over here. Notice that real numbers start with R. So we just take the R and we put a double bar over here. So this stands for the set of all real number. So this stands for all real numbers. Okay. Now what about this second function, f of x equal to x squared? We can substitute 0 into x, positive number, any positive number into x, any negative number into x. Looks like we can input any real number into this x. So looks like we can input any real number into this function. So the domain for this function will be all real number. So again, we put the R with double bar here. That stands for all real numbers. Now we call that when we divide by 0, when we have 0 under, those are undefined, which means they are not defined as real numbers. They are not real numbers. So 0 under, undefined. Under and undefined both start with U and DE. So that might be one way to remember. 0 under, undefined. Now we're trying to find the domain for this function, f of x equal to 5 over x. Now in order for 5 over x to be defined, we need the denominator, in this case is x, does not equal to 0. So the domain for this function is all real number except 0, because 0 is the only number that make this undefined. Okay, 0 under, undefined. Okay, now all other number will be okay. All other numbers will be okay. So the domain for this will be all real numbers except 0. And if I write this in set notation, so set notation is a pair of curly braces, and you put a bar over here. Over here, you put the variable, this x over here, and all real number except 0, so we'll put x does not equal to 0. So the way you read this is the set of all real number x such that x does not equal to 0. Number 4, f of x equal to x over 3x minus 6. Now, in order for x over 3x minus 6 to be defined, we need the denominator, in this case is 3x minus 6 does not equal to 0, because 0 under will be undefined. Now, you can solve this just like solving equation. When you solve for x here, then you will have 3x does not equal to 6. And then divide both sides by 3, you get x does not equal to 2. So the domain for this function will be all real numbers except 2. If you put the inset notation, so then you have all real number x such that x does not equal to 2. A remark that I would like to make here is, for rational functions, f of x equal to a polynomial divided by a polynomial, we need this denominator does not equal to 0, because 0 under is undefined. Okay, so the domain for this kind of rational function will be all real numbers except those that cause 0 in the denominator. Now, in this case, 2 cause 0 in the denominator, so will be all real number except 2.